Hello, in this video we're going to dive a little bit deeper into the backend implementation for an MMO type game. So we're going to be connecting this with Unreal Engine. So in the previous post we basically looked at an overview of what it is that we're trying to achieve and why. And in this one we're basically going to look a little bit into the code of how it achieves it. So I'll try and keep this generic enough so that it's useful for people not coding with Java and Micronaut. So for example, if you're using .NET, this should still be useful, hopefully. But of course, I'm going to be going through the Java code, so it will be particularly good with that. The GitHub code is available, by the way. I'll add a link into the description if you want to see the code for yourself. And of course, it will basically change with time as well, right? So whatever I go through today, potentially it will look a bit different in the future, but the main fundamentals should hopefully remain consistent. So again, I'll reference this diagram. So it's always good to have some sort of a diagram at the back of your mind as you're developing things, because you sort of need a target to sort of aim towards, right? So I think that this is a really good target. So this is what we're trying to achieve. We're trying to create this WebSocket server, which will send messages to Kafka. Then you're going to have other modules or microprocessors picking those messages up, processing them, send the results back, which will go back to the WebSocket, which will feed the result back to the player. So that's basically what we're going to try and achieve, and that's what we're going to go through. So let's dive straight into it. Okay, so let's dive straight into the code. So we'll begin by defining our communication socket. So by the way, I've already had a video discussing how to configure Kafka. So if you haven't seen that, or if you're interested in how to do that, I've provided some configuration with Docker Compose on spinning up your Kafka, and basically it will run on Docker. So you can see there's a Zookeeper and Kafka, and I needed to add a couple of application settings in order to link my Micronaut server with Kafka. So again, that will be out of scope for this one. I'm going to dive straight into the communication socket that basically we have here. So in Spring Boot and in Micronaut, in order to create a WebSocket, you just need to add this annotation, so server WebSocket, and you provide it a path. This path could potentially change later. So for example, I could have a different socket connection for different maps. And this is really to avoid noise, basically, right? There's no need for players in map 1 to ever even be notified about a player in map 2. So this is just some sort of optimizations that we'll do later. It's not done right now. I only have the one map. But this is where you could make that optimization so that when your sockets subscribe to certain events from Kafka, they subscribe to the same map that the socket is registered to. Okay, so when you've defined the WebSocket, there's three main things that you need to do, right? You need to define on what to do when the socket is opened, what to do when you receive a message, and what to do when you close that socket connection. So in our case, when you open it, what we need to do is basically add it to a cache. So we want to basically track the sessions that we currently have open. This will be useful a bit later on, so we'll cover that a bit later. But I basically have this concurrent set where I add my sessions to it. So this just acts as a cache. The other thing that we'll want to do is basically I don't have authentication configured yet. So when that's configured, I'm going to have some headers with account information. So for example, about the player or whether it's a server, so server or player information. So when I have authentication configured, I'm going to basically take that information and inject it into my session parameters. Because the session itself contains some parameters. So I'm going to basically store them there. So at the moment I don't have that, but that's what I will do later on when that's configured. And different authentication methods will provide you different headers or different results. So that's why it's not done right now. And I'll basically cross that bridge when I need to, sort of thing. Okay. Before I dive into the on message, I'll quickly talk about on close because that's really small. All we need to do really is disconnect the player. So, you know, feel free to change this logic because maybe you'll want to disconnect the player after a certain duration, you know, wait 30 seconds, wait 1 minute, so that the player doesn't just instantly disappear from the map. But yeah, we'll basically disconnect the player and we'll remove the session from our cache so that we don't try and process any more details using that session. Okay, so the last thing that's left is the actual processing of the message. So what is the message? So basically I've created this model, and this model will mainly consist of these three fields, I guess. So there's going to be an update type. So the update type refers to, what is this message actually trying to achieve. So at the moment, I'm really supporting two main things, which is player motion updates and monster motion updates. And that's why I have these two extra parameters, one symbolizing the monster. So this has things like your motion information and the mob instance ID, and then the player motion, which very similar, has the player's motion, player name, and things like that. Okay, so we don't really need these two things, or rather these four things. I've just added them to simplify some of the logic inside. And these two, I think, will go away once we've got authentication running. So at the moment, I don't have any authentication enabled. So I basically just hacked some stuff into the payload of the socket message. And that's why I have this here. To be honest, the player name may be kept here because when we do authenticate the account, you're going to get account information rather than just the player that is playing the game. So perhaps I will keep the player name part of the socket message. Okay, and let's go back into the processing of the message. So I'll cover a little bit more about the update session parameters, but that's just basically taking the session and taking some useful parameters out of the message and injecting them into the session parameters. So this would be like the player name, the server name, or the current motion. So we'll cover those a little bit later when we actually need that data. Okay, so we're going to look into the processing of the message. So again, I'll just reference this thing. So we're still on here. And what we're about to look at is how to send the message to Kafka. Okay, so let's open this back up. We do that sending based on the update type. So basically the socket message contained a field called update type, and this could be things like player motion, create mob, mob motion, player combat, mob combat. Like this list will go on. So I'm going to try and make this a bit more pretty. You could have a switch statement, but switches don't work with enums here. So potentially I'm just going to have a map of types to functions. And that way, basically, we're just going to take the message, evaluate it based on type, and send it to the right function based on that. So, but for the time being, it's a simple if statement. So, for example, if the update type equals to player motion, we're going to execute this function. And what we're going to do is send the player motion update. So you extract the player motion information, so it's this one over here, from the socket message. And you send it using Kafka. So there's an interface here for the Kafka client, and you basically send the player motion update using this one. So the cool thing about Spring Boot and Micronaut, so in the Java space, is that these frameworks actually do that work for you. So all I need to do is basically specify the topic and the message content that I wish to send, and the actual sending of this message happens under the hood. So the framework does that for you. So it's pretty awesome with that. And that's all that this guy needs to do. He just basically evaluates what is your update type, and based on the update type, it sends it to the correct place, right? So for example, if it's create mob, it basically sends the monster object from your socket message to here, right? So it sends it to this topic. Okay, so that's sort of the extent of the WebSocket server over here, right? So this is part of the sending. We've not looked at the receiving yet. So let's basically now look into the Kafka part and who's going to be receiving that message. So what you're going to have to also see here is that at the moment, my server is not really a microservice, right? Each of the services are basically split into modules. So in theory, you can take any one of these modules and split it into its own microservice. But I don't want to have the overhead right now of dealing with many different services, right? So I just basically bundled it all together. And yeah, like in the future, potentially you'll split each module into its own microservice. So when we basically send this update, you're not just calling a function from a different module, you're actually sending this message into the Kafka. So basically, this Kafka will receive that message, and it will basically check, is there any subscribers to it? And the subscribers will then receive that message. So what I can do is basically search for anything referencing this topic. So here's me sending the message. So there's my Kafka client. So this one is sending the message, and there's going to be one which will basically listen to it. So there's my Kafka listener. So this is the one that will receive this message. Okay, so now we're basically at this point. So the Kafka client received the message, and it then says, is anyone listening to this message? And then it sends it to one of these modules, which says, you know, I'm a listener, give me that message. Okay, so now we're basically at one of these points. And here we can call this player motion processor, for example, right? Okay, so this one received the message, and at the moment it's not actually doing that much, right? So what we'll need to do is things like validating that request, validating that message. And to be honest, you know, I don't want to underestimate this. The validation is actually like a pretty complicated part. And this is mainly to avoid hackers, right? So if your client has been compromised and it's sending some dodgy data, you want to actually reject those updates, and you don't want to be passing those through. So you can confirm them by basically checking the previous state and seeing, you know, does this new motion even make sense? And you can just simply reject it. Or not. Okay, at the moment I'm not doing any validation. What I'm going to do is subscribe to sending this to our MongoDB. So I'm using a reactive framework for that. So basically update player motion. So you can see here I'm returning a single, and the single is using a reactive library. So basically I can subscribe to it. So we want to avoid any blocking calls. So for example, I could say .blocking get. And this would make this a blocking call, and we basically want to avoid that, right? So everything will happen with the writes at least async. So the validation should probably be done in serial, because you want to validate before you decide to persist that information and then relay it to others. But the actual writing can happen async. Okay, so then after we basically do some processing, so after we validated it, after we put a job to write it in the background, we want to relay this message back to other WebSockets. And again, what we have to bear in mind is that you can have multiple of these WebSockets, which means that you can have players on other sockets, which are within the vicinity of your current player, but just, you know, on a different socket, right? So they also need to be made aware of this player's motion. So that's why we're using Kafka again. So in a very similar way, you will actually have another Kafka client which publishes the results. Okay, so this one is player motion update result. So if I now search for this one, back on our socket module, so back on this module over here, we actually have a listener as well, which listens to results for any of the work that's being handled. So that's basically part of here. You see there's a result X. So this one listens to the player motion result. So you can see this one listens to a monster result. This one is a player motion result. And it basically then says, okay, take this player motion and send this update to any clients that are listening. And we'll have to imagine that there's going to be a different number of WebSockets listening to this message. And this is again where you'll have to subscribe to relevant notifications. So for example, if your WebSocket is only listening to map 1, you'll want to subscribe to topics specific to map 1 updates as well, so that you avoid that pollution of noise. And really you can start making things smaller and smaller as your population goes higher, right? But otherwise, you know, this should scale pretty well. Okay, so how do we send the updates? Well, first of all, we create the socket response. So the response is basically, why is this message over here? So again, we specify the message type. So here we'll basically say that this is a player motion update, and we'll basically add some player keys and the player motion. So the player keys are actually part of this map, but with the library that I've been working in Unreal, I'm not able to basically extract these keys natively. So I'm going to remove these a bit later, but just for the purposes of MVP, I've added them because it made my life a bit easier with UE development. So this is just duplication data that's inside here. So this is part of some of the optimizations that will have to be done on the server, as well as, basically sending JSON is not the most efficient thing either. So we'll potentially be converting these to more compact messages. But this is way easier to read, way easier to understand. So that's why I have them like this for the time being. Okay, so we construct the socket response and then we broadcast it. The key here is this is valid function, right? So we basically broadcast the player motion to anyone that's listening, and the thing which evaluates whether the socket is listening to that message is through this is valid function. And by the way, this is also done via async method. So basically you subscribe to this rather than telling it to basically block this thread and do it right now. Okay, so let's check is valid. Okay, so part of is valid is where we basically check whether the session should get the message. So the way we achieve that is through some of the session parameters that we populate elsewhere. But basically inside the session, we will store a number of parameters. So we can basically get the session as map, and then it contains a map of data, right? So we need some keys to get the values. So this is all pretty custom. So I basically added this enum to hold the keys that I'll potentially be using. So at the moment, these are the data that I'll support in the session properties. So the two ones that I'm looking at specifically here are the tracking players and the tracking mobs. So I add some parameters with these keys, tracking players and tracking mobs, and they just symbolize the players that are nearby this player or mob, right? And the session represents the player or mob. So if there are other players within your vicinity, they'll be inside these parameters. Okay, so we'll look at how we populate those a bit later. But we basically just assume that if a nearby player exists, they'll be part of this player's parameter, okay? And all we need to do is just check, do these sets of data, which is just a list or an array, contain the player or mob that we're basically processing right now. And if any of them are true, we basically broadcast that message to those sessions. So this is done per session. So for example, if this server is catering for 50 sessions, it basically checks each one, should I send the message to this session or not? Okay, so that's how this part works. And this is again where the optimization of making sessions connected to particular maps or zones goes a long way basically, and it's just really to reduce the amount of noise so that you don't need to actually check even, right? Because you know that they're not nearby, so you don't even need to check. Okay, so okay, that is valid, and yeah, if that's valid, then you basically broadcast that message out to those players and they'll receive that message. So I guess perhaps now we can look at how do we populate those variables in the first place, so the session parameters. Okay, so right at the beginning, basically, we had this on message, and straight away we updated some session parameters. So we'll take a quick peek into what this does. So what I want to mention is that this will probably go away. So we're injecting some player name and the server name from the socket message because our onOpen does not currently support that. So they'll actually be populated through the onOpen a bit later. So I'm not going to delve too much into that. But the more key thing here is that we're extracting the motion information from the message whenever it exists, and we're putting it into the session parameters. So perhaps rather than motion, I'm actually going to extract this as location instead, because we're not actually interested too much. Well, actually, maybe we will be. When we're doing validations, we'll probably be interested in the rotations for the actor. For the time being, we're actually mainly just interested in the location. So what we're going to be doing with this motion is actually evaluating who's nearby this player or mob. And rather than mob, it's actually a spawn area rather than an individual mob. So when we'll look at this a bit later when we're looking at the UE side of things, but your UE server, rather than creating a separate WebSocket for each monster, we're just going to create the one WebSocket defining a spawn area. And this is really just to optimize it, because otherwise, well, there's basically no need to have so many different sockets if the mobs are nearby. So if the area is overlapping, don't create additional WebSockets when you don't need to. So the mob will actually represent a spawn area rather than an individual mob. But the messages themselves will be for individual mobs. Okay, so so basically we extract the motion from the message whenever it's present, and this basically means that the mob's motion was updated. So what we're going to do with that is start synchronizing them, and this happens async. So part of the socket module, the one that's basically dealing with all of the comms, I have this class. It's called Synchronize Sessions Service. And what it will essentially do is run this function every 1 second, which we can change to whatever we like. I think 1 second is fine, which will evaluate nearby players or mobs actually, right? So what it does is every 1 second, it grabs all of the live sessions. So this is where the cache is actually utilized. And for each one, we go through them in parallel. We take the player name and we take the motion, and we basically evaluate all of the nearby players async. So the reason why I extract is server is because servers will have a different threshold distance to players, and this is because they'll represent a spawn area which is larger. Okay, so you can see here that the distance for players threshold is 1000 units, which means that you should be able to synchronize any players or mobs within 1000 units from you. So if you want to change that, you can change it here. Mobs will have a larger threshold because they cater for a larger area. So it basically synchronizes anything within 10,000 units of your motion. And yeah, basically for each session, we get the nearby players. So we do this async. This is a call to MongoDB. So we basically say, get me anything that's nearby this motion. This is the player name that we're currently on. So don't give me that player's motion because, I am that player. And the distance threshold. So again, this happens async. So you can see it's subscribed to this. So this way we're not blocking this thread from continuing other work. And when it's successful, we get a list of all of the player names, or rather, it actually gives you a list of motions, and we extract the players' names from that motion. And what we're actually going to do is evaluate whether any of these players are new, or maybe some of them are lost and things like that. So I have this function which basically takes the current list of players which are nearby, and we check are any of them new, basically, right? So the previous tracked are the player names that currently exist on your session. So you can see me grabbing my session, and then I'm getting the currently tracked players, and this is a set of strings, right? So this set of string contains player names that we've been tracking before, and then I check who are the new players, right? So if your current player names don't exist in the previous tract, then they're new players, right? And I'm going to need to do some things with new and lost players, because I also evaluate whether any of those players are lost. So perhaps we had some players before which are not there now, which could mean, for example, they came out of the distance threshold, or they've disconnected, or anything like that. So we also want to handle them. So if it's a new player, we're going to want to fetch additional data. For example, we'll want to fetch their appearance information, which again happens async. So we say handle new players. Do we have any new players, right? So if we do, we want to handle resolve the motion for those players. So we have character names at the moment. So we want to send the motion information, and we also want to send the appearance information. All of these things happen async. So basically, resolve character appearance, for example, you have this set of new players. You basically go to the server saying player character service, get me the characters by names, and when it's successful, you're basically going to get this character map, and this character map contains things like your appearance information, and then you create a job to send that information to the session. And again, all of this happens async, right? So you're basically creating promises to do the work, and then when it gets to it, it does it basically, right? Okay, so and when the character is lost, you basically send a response to say, you know, don't synchronize these players anymore. So we can have a look at that as well, actually. So where are we? Handle lost players. So we basically send a message to say that these players are no longer there. And what we do with that message on the Unreal Engine side is we basically delete that actor and we stop tracking it inside Unreal Engine as well. Naturally, you overwrite the previously tracked mobs on the session by simply setting it to whatever the new one is, right? So all of this happens basically async, and then you overwrite the session parameters with the current players. And you basically do the same thing for mobs. The one distinction between mobs and players is that server instances don't care about mob updates because they are the ones tracking the mobs, so they already currently exist inside the UE instance, so there's no need for them to get notifications about mobs as well. So the UE server will only get updates about the players, and the players will get both updates about other players and mobs as well. And that's basically it for now. So what we can perhaps do is add maybe some logging, so you can see it happening in like basically in conjunction with UE engine. So let's assume we have this on message, so perhaps process message. Maybe it will be interesting to add something maybe here. So for example, log.info, and maybe we'll add message.get player processing player motion, and let's add the message player motion. So what we'll do is we'll let this compile. We'll start this up in the background, and what we'll do is we'll open up our Unreal Engine instance, and then we'll log in as two players, and we'll see it trying to send those messages. So this will be sending it over to Kafka at this point. So I mean, really, it's just to sort of demonstrate that it is in fact processing the messages through this server, rather than, for instance, using UE replication or something like that. So we're basically keeping track of all that data here. Okay, so now that it started, I'm just going to open up the UE engine. So here we have the two clients. So I'll log in as character 3 on one of them, and maybe character 4 on the other. So here's our characters. I've left a couple of things in there. So basically, when I move around, you can see that basically the characters are being synchronized between the two clients, right? So you can see I've also applied some smoothing on the character as well, so they're not really teleporting around, right? And all of these messages are going via here. So if I basically scroll down, you can see that these are the messages received. So perhaps what I'll do is I'll open up the smaller one. So you can see it's basically sending all of these things. And I've configured it to send it every 100 milliseconds. So you should be able to see that over here as well. So let's have a look. So yeah, basically every 100 milliseconds, we're going to get a new message. and it's basically taking that, pushing it to Kafka, letting it do its work, getting the message back to Kafka, sending it back to the socket, and then broadcasting it to any relevant clients. So that is the backend working in conjunction with the UE client. And perhaps what we're going to do next is a look at how the UE client itself is integrated with the server. So we're going to look at how do we configure the WebSocket inside Unreal Engine, and how do we process the response messages, how do we send the motion updates and things like that, and yeah, basically get this to work. So I think that's it for this one, and yeah, best of luck and see you next time. Thanks.